I woke up today morning and realized, oh, this is 18th May today, another Thursday, and I need to give answers to the SQL Server indexing questions that I posted last week. So last week on Thursday, May 11th, I had posted a video talking about SQL Server indexing questions. That video only had the questions, not the answers, because the idea was to get a few responses from you, from the community, and a few answers came in. Thank you so much for that. In this video, today's video, we are going to talk about the answers to those questions. So don't worry, you don't have to go back to the video of last week. This video will have the questions again, and we will talk about the answers. So just a quick recap, these series of videos that I'm talking about, I'm recording, are focusing on different topics in SQL Server. And the level of questions will also vary a bit. So I've started with, let's say, SQL Server indexing questions, and the level is basic. So the next set of videos will have level like intermediate and then maybe advanced to expert level. So let's jump into action right away. This is SQL Server indexing questions and answers, part 1, level basic. So let's go and repeat the questions again. So we'll start with question 1. So the first question was, can you create a primary key with a non-clustered index? And here is a very quick example first. Okay, we are using AdventureWorks 2016. You have a table in front of you, production.transaction, history, archive, etc. I don't know why we have such long names. Anyway, so now if you look at this SQL construct here, you're creating this table and you're adding a primary key constraint, and you know that by default, this will create a clustered index. You're not specifying anything here, but you know that this will be a clustered index behind the scene. Or to make it more clear, you can always just add clustered as well, which would mean the same thing. So the question is, instead of the clustered index, can I tell SQL Server to create a non-clustered index instead? So can I just say non-clustered, and will this work? Well, by the question itself, the most likely if I'm asking this question, and if this question comes across, probably in most cases the answer is yes, you can do it. But then I had a follow-up thing which I did last week in that video also, and I will do that again today. So the answer is yes, you can create a primary key on a non-clustered index. Yeah, you can do that, very much doable. But the follow-up question is, why would you do that? In which scenarios do you think it's a good idea to have the clustered index on some other ID, and maybe have clustered index on some other attribute, and you can have your ID, let's say primary key, with a non-clustered index. So let's jump into explanation, and I've just created a small academic prototype to kind of explain this better. Let's get started. So what I'm doing is I'm creating a copy of this table called sales order header. Let's do that. Select this, and I'm going to turn off the actual execution plan. Sorry, it was turned on. So let's go and execute this. So we have a copy called sales copy, which has about 31,000 rows. Let's look at this table and see the kind of attributes that we have here. So we have sales order ID, and then we have some columns related to date, order date, due date, and ship date, etc. Now, I've taken this particular table as an example on purpose because this kind of fits the scenario so very well, the kind of thing that I want to explain. This is an orders table, and an orders table will always have an order ID, right? So you have the sales order ID here. And this is an orders table, so it's bound to have multiple attributes that will talk about dates, like order date, due date, and ship date. And of course, out of these, maybe the order date is kind of more important from a business application or from user perspective. Many users are going to search on this table, right? And they will use this order date quite frequently in their reports or in their select queries, like give me last 10 orders, order by order date, or between a particular order, like the start date and the end date, between two order dates, so kind of range scan, etc. They're going to be, okay, give me the all the orders starting from 1st Jan 2023, something like that. So you see, variety of constructs are going to come in. where order date is going to be put in the where clause, and you will have all sorts of filtering happening. In that scenario, it will be a great idea if the data in the table is sorted by order date. Yes, the moment you create a primary key and you let SQL Server create a clustered index, the data is sorted by that particular attribute. Now, if you're telling SQL Server to create a primary key with a non-clustered index on some other attribute, and you specifically tell SQL Server, you know what, go ahead and create a clustered index on order date, then you have the data. Remember, a table in SQL Server has data pages, 8 kilobyte pages. They are physically sorted on the disk, next to each other, ordered by this particular attribute. So, just to discuss as a wild example, let's say you have 10 pages and each page has orders data. So the first page, let's say, has January data, the second page has February data, the third page will have March data, so on and so forth. And they are going to be physically laid down on the disk next to each other. So you have like Jan, Feb, March, April, so on and so forth. And then if the data is laid down, is arranged in that fashion, it becomes very easy for SQL Server to just go and grab that data, because your queries are of such fashion. So you're asking for these range scans, or your filters where you will really be benefited with the data being put into sorted order. Pre-sorted is the idea. So order date becomes a very, very good candidate for the clustered index. Now let's talk about the primary key and the non-clustered index. Of course, no brainer there. You would go with sales order ID. Sales order ID is the primary key because it has to be unique. Remember, when you have a primary key and by default SQL Server creates a clustered index, it is actually a unique clustered index. Now this is going to be a unique non-clustered index, and sales order ID will just serve the purpose real good, because this is an ID column and you might want to use this attribute to join with other tables, and then join keys with this attribute will really serve good, when you're using this particular attribute as the join column. Yeah, so perfect. Let's go ahead and see this idea. Let's put it into practice and see the benefit that you're going to get. Okay, so I explained you the structure now, and this is what we are going to do. We are going to create clustered index on order date, and sales order ID will be primary key with non-clustered index. And let's see what benefit do we get. So SP help index, let's go and check this. Yes, it is a heap right now, and the pages are just laid down in random order, no specific order. So this is a heap, no index whatsoever. Now we are going to create, we are going to add a constraint, primary key constraint. Now this, will create a clustered index, a unique clustered index by default. So let's go and execute this. And now I want to execute. Okay, you want to first see whether we have the index there. Okay, let's go and do SP help index, and yes, and then you can see clustered unique primary key located on primary. Too many times primary. Don't get bogged down with that. Well, this primary word at the end has nothing to do with primary key. That means the primary file group. Okay, so it says it's a clustered unique primary key located on the primary file group. We have that. Now I want to show you something. Let's say your query was something like this. Select start from sales order data, order by order date. Okay, and you don't have any index on order date right now. So let's turn on actual execution plan, click on execute, jump over to the execution plan, and you can see that SQL Server has deployed a sort operator. Now this is what we will fix now by changing the structure a bit. So what I'm going to do is drop this constraint, this primary key constraint. Okay, let's go and execute this. Dropping this constraint here is relatively very easy because this is just a dummy table. Real world things are different. You'll have a lot of these foreign key relationships, etc. Anyway, now what we are going to do is we've dropped the constraint. We're going to add it again, and this time you can notice the keyword here, primary key non-clustered sales order ID. So I'm telling SQL Server specifically that, create a non-clustered index, not a clustered index. Let's go and do that. Execute, job done. Let's do SP help index just to show you the difference. Now the metadata clearly tells you that this is a non-clustered index. Great. Now what can you do? I can go ahead and create a clustered index. Remember, you can create only one clustered index because there's only one way how you can physically sort the data, but you can create multiple non-clustered indexes. So we're creating a clustered index on order date. Very straightforward syntax there. Let's go and execute this. And guess what? Now, if you do this, the same query again, select from sales copy, order by order date, what will you expect? Let's turn on the actual execution plan, click on execute and jump over to the execution plan. And there you go. There is no sort operator anymore. The sort operator vanishes, goes away. Yeah. You know, these are the kind of tricks that you could apply to even improve query performance. So this was a good example of indexing architecture, index tuning, and query tuning overall. Yes, so this first question was, can you tell SQL Server to create primary key on a non-clustered index? And if you can do that, what are the advantages, or why would you do that? Scenarios. There's always not a straightforward yes/no answer because it all depends on the scenario. And that's why I took this orders table as a good example, a great example where order date is a perfect candidate for a clustered index, and maybe a sales order ID as an example for a non-clustered index. So that is the answer to the first question. Now, let's move on to the second question. Let's scroll up. Here we have the second question. So in second question, we are asking what's the difference between option 1 and option 2. So you're creating a non-clustered index and your choice of columns here are postal code and city. So you have two different ways of doing it. In the first example, you are creating this index, non-clustered index, and you have put postal code and city both as index columns. So this is like a multi-column index, a composite index structure. Both of them are index columns, right? Postal code is the first column and city is the second one. In option 2, you're creating this index on postal code, which is the indexing column, and you're telling SQL Server to include city. So city gets included as part of the index structure using the include keyword. So of course there is a difference between both of them. So the question was, what's the difference between option 1 and option 2? And of course, when you understand the differences between these two options, you would be able to design better indexes and you will be more informed as to how SQL Server engine behaves. Okay, so let's jump over to the answer. The answer is, when you put, let's talk about the second column, right? Because postal code is anyway the first column in both these cases. When you put a particular attribute, a column, as part of your indexing columns in a multi-column index, all the columns here are part of the B tree structure. So you know that index is a B tree structure. You have the root level, the intermediate level, and the leaf level. Leaf level is the actual data. So you have like a layered structure: root, number of intermediate levels. Root is always one page, then number of intermediate levels, and then you have all the pages, the actual data at the leaf level. So the attributes that you put as part of your indexing columns, they are contained even in root, intermediate, and of course at the leaf as well. So how does that benefit SQL Server Optimizer or the engine? Well, you can seek on both postal code as well as city. That's the idea, the seeking capability, because both these attributes are available at every level of the B tree structure. The SQL Server engine can actually go and seek on both of them, and traversing of course becomes faster. So that is the case of first one. Now in option 2, when you take the city out of the indexing column and you put that as part of the index with the include keyword, what happens? The change that you will notice here is that city as an attribute now will only be available at the leaf level. It is going to be contained only at the leaf level. It will not be there at the root level and the intermediate level. which means that now city as an attribute is available for the purpose of retrieval, so that SQL Server engine does not have to go back to the base table. You have the data in the index, but the engine will not be able to seek on city. That will be a catch here, and that's an important catch because it's sometimes not very evident from the execution plan, and I'm going to show that to you in a while. It's tricky actually, because when you have both these indexes and when you look into the execution plan, both the operations with option 1 and option 2 will actually show you as an index seek, but there is a catch in option 2. So I'm going to repeat. In option 2, you cannot seek on city, you can only seek on postal code. City is just included, and that's why the keyword here include. City is just included as part of the index structure, so that the retrieval becomes extremely fast. The engine does not have to go back to the base table. All the data that the query needs will be available in the index. And when I say all the data, I'm coming to the select statement in a moment. My select statement is only talking about postal code and city. That's why if you are talking about more attributes, then of course it has to go back to the base table given these indexes in consideration. Okay, so that's option 1 and option 2. In option 1, I have postal code and city both in the B tree structure, and I can seek on both of them. And in option 2, I'm only intending to seek on postal code. I might not have a need to seek on city, so I just kind of include it in the include keyword. Now let's look at this in action explanation. Yeah. Okay, so I'm again going to make a copy of this table called person.address as address copy. Let's do that. Okay, job done. And in option 1, okay, so here is the query, right? Select postal code city from person.address copy. I'm only playing with these two attributes, and there is a postal code here and the city Warwick. I know this from the data, so I've just punched in and I'm going to turn on the actual execution plan. It's already turned on, so let's go and execute this. Jump over to the execution plan, and what you see right now is a table scan, and obviously I just created a fresh table using select into, so this does not have any index. Now we are going to create a non-clustered index, and this is your option 1. Let's do that. Okay, you have both postal code and city in the index formation. Now if we execute the select statement and jump over to the execution plan, what you can see is an index C. And this is perfect. This is what you wanted. You're seeking. Now behind the scenes, you're actually seeking both on postal code as well as on city, and this is important to note here because your select statement also has postal code and city in the where clause. So you and it's in this particular order, right? Postal code and city. So you know there are more things about having both the attributes in the where clause or only one of them, and if you're one of them, which one do you have? Only postal code or only city? So that discussion goes into a different tangent. Let's not go into that world right now. Let's only understand what's happening behind the scene. So behind the scene, SQL Server is nicely seeking on postal code as well as on city. So I'm going to zoom in here a bit, and I can show you that there is 3 sections here. If you look at the bottom, you have object, output list, and what we call as seek predicates. So both postal code as well as city are being listed in the seek predicates because they are seekable predicates, and SQL Server is able to seek on them. So what I'm going to do is, if I want to show you the difference. So let me just see if the snip tool works. Okay, let's okay, snip tool. Okay, no, snip tool will actually not work very well because is there a shortcut there button? Okay. No, I actually wanted the tooltips. I'm not very comfortable doing this one. But anyway, this one, I wanted to highlight this actually, and I wanted to compare both the plans and show it to you. But anyway, you can try this and remember this yourself. So I'm just going to do this once more. Show you that you have 3 sections: object, output list, and seek predicates. There is a section called residual predicate which is not there right now, and you got to keep an eye on that. Okay, now this is all going good, so let's go and drop this index And now we will create the other index, which is option 2, and I'm going to put city in the include keyword. Let's go and do this. Yes, come on, and we are done. Now let's go and run our select statement again, exactly the same statement. Now you know that city is not really part of the index columns, but it's there in the include keyword. Let's go and jump over to the execution plan. The first thing you're going to notice is that this is again a seek, and you're going to ask me, hey Amit, this is seek earlier also and this is seeking now also. What's the difference? The difference is this. If you take the cursor over here now and look at the tooltip, look at the sections below, you have your answer. You can see object, you can see output list, you can see seek predicates there. Now look at the seek predicate there. In the seekable predicate, you only have postal code. Where did the city go? City is no more a seekable predicate. And you are going to find city in a new section, which is listed here. And can I just draw this? Yes, I can. And you can see something called as predicates here. So this is your residual predicate section. And here you will find all the predicates on which the engine was not able to seek. And you can see city is up there because you've put city in your where clause, right? So you say where postal code is something and city is equal to something. So SQL Server is able to seek on postal code because it's part of the index column and it is available in the root page and the intermediate page. But city is not available in the root page and the intermediate page. So this becomes a residual predicate. And SQL Server has to then, of course, go and scan the leaf lever to find the matching records where city is equal to Warwick. That is the difference between option 1 and option 2. This one and this one. So this kind of clears out a lot of concepts around indexes. What's the purpose of include and why it will be good or bad, and structurally behind the scene, how does SQL Server deal with storing the data as well as when you are going and retrieving the data. So this was question number 2. And yes, when we are talking to our colleagues or even when I'm hiring new folks from the SQL Server world, I ask these questions. These are very basic questions. And I just tell them, okay, you have option 1 and option 2. Just explain what's the difference between these two. Hope you enjoyed question number 2 and the answer. Let's jump over to the third question, question number 3. The third one is relatively very easy. In fact, the third question actually gets answered in the first question itself. So, the query is something like this, right? Select postal code from person.address, order by postal code. Okay, so let's go and execute this and jump over to the execution plan. And you can see that because where's the query? Okay, there you go. Okay, so we are only retrieving postal code and we want to order by postal code. And if you jump over to the execution plan, you can see that SQL Server actually deploys a sort operator to sort the data, which means, of course, the data is not sorted by postal code. So what can you do? If I create a non-clustered index on postal code, can SQL Server get rid of the sort operator? Very straightforward, because the moment you create an index on an attribute, the data is sorted on that attribute, be it a single column, index formation or multi columns, the data gets sorted by that. And because you're only talking about and asking for postal code, you have all the data available in the index. So all SQL Server has to go is just scan the data and bring it back. And it is already pre-sorted, pre-ordered. So, there will be no sort operator. This was answered in first question itself, but let's go and see this. So let's go and create this index, done. And let's go and select again and jump over to the execution plan. And yes, there is no sort operator here. Okay, can I draw that cross? Very nice. Great. Hope you enjoyed these 3 questions. Focusing on SQL Server indexing. You can test yourself, self-assessment, you can test your colleagues, and you can test new talent as well. This was SQL Server indexing questions and answers, part 1 at the basic level. More videos to come. Do subscribe to the channel. Happy SQL.
If you like the content, give it a thumbs up, subscribe to the channel and click on the bell icon so that you're notified on new videos. Most importantly, visit SQLmaestros.com. There's a lot of SQL learning resources out there, video courses, master classes, lab kits, ebooks, blogs, hands-on labs, and a lot more. Follow us on Twitter @SQLmaestros and myself _Bansal. Last but not the least, do subscribe to our newsletters. See you soon in another video. Goodbye.